This year, I started volunteering to help with a holiday light display at my local botanical garden. It's known as Garden Delights. One goal this year was to have a branded photo opportunity with the name of the display so that people could take their pictures next to it. We talked about it during the summer, but I put it off to work on a higher priority project. See my animated LED arrows video for a description of that project. I therefore only had a few weeks to do this project. The design is simple. The back is made from 1/8 inch black acrylic, black because the sign itself needs to not really be visible. Attached to that is the light source, in this case a strip of 294 warm white LEDs cut into 7 segments. In front of that, there's a space of about 4 inches. The front is made up of 2 sheets of acrylic. The back of the front is a 1/8 inch sheet of 2447 translucent white acrylic that functions as a diffuser for the light. And finally, the front is a second piece of 1/8 inch black acrylic with the letters cut out. The basic sign design was done in Inkscape, which is normally what I use for two-dimensional design. I got the font, known as Family Holiday, from the person in charge of communications for the display, so getting to this point was simple. The next step is to convert the text to a path using Object to a Path. This is required because laser cutters don't have built-in fonts, so they need to cut on a path rather than know what the text is. Note that when you do this operation in Inkscape, it groups all of the generated paths together, so it looks like the conversion didn't do anything. You need to choose Ungroup if you want the individual letters represented, as they are here. Then I had a problem. The sign needed to be big, but my Glowforge laser cutter has a limited cutting area that is much thinner than the 33-inch width of the design. My solution was to divide the letters into 2 sections. The blue section will be cut from one piece of material, and the red section will be cut from a second piece. Most laser cutters will let you segment your cutting based on the color, so it's easy to cut just the red, or just the blue. The rectangles around the words are required so that the height of the 2 sections will be identical, and they will fit nicely against each other. One of the challenges working with acrylic is that conventional tools don't work well. They produce a poor cut edge and can even crack the plastic. For this project, I bought a Freud blade with a specific tooth design for cutting acrylic. At $90, it's an expensive blade, but it works wonderfully. I bought the plastic slightly oversized so that I could trim it down to the final dimensions. I originally ordered my acrylic from Piedmont Plastics, but ended up buying the same materials from my local Tap Plastics when the timeline ended up being shorter than I expected. There's about $100 of acrylic in this project. Because the cuts are pretty much the maximum size possible with my Glowforge, I needed a good way to align the plastic in the cutter. I did this by putting blue tape down on the crumb tray and then cutting the maximum sized rectangle on a very low power. That generates a light white marking on the tape that I could then use for alignment. The blanks were then cut on the laser cutter. Each of these sections took about 10 minutes to cut. The next step is to peel off the paper from the acrylic, which took a lot more than 10 minutes. Each of the blue labels indicates a part of the lettering that is not connected to the main sheet, and the code indicates where each piece goes in the sign. Before I pulled the sheets out of the laser cutter, I marked each of those pieces, and then remarked them with the tape when I peeled off the paper. That way I know where each of them goes. At this point, I've glued the 2 big sheets to the translucent acrylic sheet. There was a little light leaking between the 2 sheets when I held them up, so I taped them together with a strip of the aluminum tape used to seal ducts. You can see this on the top and the bottom at the center of the sign, and on the enlargement on the right side. Above the sign I have a printout of the design and a prototype that I made, so I can put those pieces back exactly in the right location. The blue tube is the acrylic adhesive, which is mostly methylene chloride with a little plastic dissolved in it. It works fine, but the solvent is so volatile that the glue you squeeze out is only good for a minute or 2. After all the individual pieces are glued in, the front panel is all done. Next up is making the frame to hold the front and back panels. It's made out of some 1" by 10" PVC board that I had left over from another project. The slot for the front panel is made with a 1/4-inch router bit, and the one for the back uses a 1/8-inch bit. Here the frame piece is partly assembled and welded together with PVC cement. There are also stainless steel screws holding the frame together. For the back panel, I knew how long the strips would be, and I needed to figure out the spacing for the strips. I did calculations on paper, but then I decided the simplest way to do it was to fire up Fusion 360 and create a design to create the pattern that I wanted. I exported the design to Inkscape so I could create these spacing strips, which were then taped to the plastic. The spacing strips are used to properly space the LED strips. This is a completed board. I was going to wire the strips in series, but there was considerable voltage drop even at the end of one strip. So each strip is wired to some 14-gauge copper wire, and then wired to a cord that will supply power. Power is provided by a 12-volt power supply that lives in a plastic storage container inside a garbage bag in the grass behind the sign location. It's connected with a 15-foot cord and a waterproof connector. Here's a picture of the completed sign, and the sign on the arch where it will live at the display. Thanks for watching. I hope you found this project interesting.